have an example using the impulse momentum theorem to find the impulse required to stop a person that's falling. So this is a daredevil, and I'm going to start by indicating my coordinates. So I'm going to take the y direction to be the positive direction. And with conservation laws, we want to identify what our initial state is and what the final state is. And I want to use those two and connect them with the conservation law. So here we have, for our initial state is our daredevil falling. And it's given in the problem that they're falling at their terminal velocity. The impulse momentum theorem is about vectors, so we need to make sure we're using vectors correctly. So the initial momentum is going to be the mass, which is nice round 100 kilograms, and they're falling at their terminal velocity, which is 50 meters per second down. So the initial momentum is going to be minus 5,000 kilogram meter per second on the y direction. And so these are what we have for the units of momentum. It doesn't come up all that much, so there's not a separate derived unit for momentum. You could call it a Newton second, or you could call it kilogram meter per second. All right, in the final state, our daredevil has been successful, and they are at rest. And that momentum is, well, since they're at rest, just 0. So then we apply the impulse momentum theorem to find the impulse. So it would be the change in momentum, and change is always going to be the final minus the initial. So final momentum was 0. We have minus minus, so it's going to be plus 5,000 kilogram meter per second. And that is what the average net force acting on the daredevil has to be to stop. It could be a very large force acting for a short time, or a very gradual, gentle force acting for a longer time. But however I'm going to make this combination of impulse is going to have to equal 5,000 Newton seconds, or 5,000 kilogram meter per second. And that is our impulse.